Welcome to the Machine Learning at Home. So today my title is Median Learning. However, it is again mostly demonstration of basic principles of machine learning, which intend to help you understand the whole process better. In particular, I like to explain more about what is a model and prediction process. So first of all, we as usual start with the creation of train and test datasets from the dataset which is embedded into R, the ARIS dataset. So ARIS train would be, for example, each fifth row, so we'll make a logical selection like we frequently do. Repeat false 4 times and then true 1 time, and also REP, and finally after the all parentheses comma and space. Sounds like I made it right. Again, and the testing will be the same almost, with exclamation mark for the negation. So falses will become truths and truths will become falses. Okay, done. Now I like you to look on that particular table which I will create soon. So there is a very powerful R function aggregate. Aggregate do two things. It will split data sets in multiple subsets, and then for each subset, for each variable or column, it will calculate some value, which value you will decide yourself. So I like it to split ARIS data by species, and for each species calculate the central value of numerical characters. So I will take 4 first variables from the ARIS train. So everything but without variable number 5. Then I will use for splitting that excluded variable number 5 slightly unusual way of selection because I want my object to be a list. So this is not so important at the moment. Please remember how to select for aggregate. And now my function, what I would like R to do for me. I like to calculate median. And this is it. So now like my function will split training subset in 3 parts according to species, and for each 4 variables in each 3 parts, so 12 times, we'll calculate median. So now we have 12 numerical values. What are they? They are median values, so this exactly centers of each species distribution, each species character. So please pay attention on petal width of this last column. To me, these values are very promising. In what way? They're promising how well they are spread from each other. Look, like Setosa has only 0.2 width, very narrow. Versicolor is broader, it's 1.3. Finally, Virginica is very broad, it's 2.1. And these 3 values are set apart very well. If you look on 3 other characters, they're not so well set apart. So I hope that petal width will allow us to split dataset by species. Without 3 other characters, we just use 1 of them, 1 instead of 4. But of course, to decide which one is better, we should look on all 4 of them. So now I will select these last values because I like to work with them. So first of all, I'll repeat my command and we'll make, for example, gg object from it. Okay, and now I select the last column, gg petal width. So this is it. So we now have 3 numbers which originate from trained dataset. Now, my logic is, if I apply these numbers to the test dataset, we might split test dataset in such a way that each of 3 parts will correspond to the species. So data around 0.2 will be Setosa, data around 1.3 will be versicolor, and data around 2.1 will be virginica. So sounds logical. That will allow us to use just one best character to predict the species. But it's not all. We need also to make our to do it. So there is a very powerful command, cut, C-U-T. But to apply this cut, you need not central values, but breaks. So we need to define breaks. First of all, leftmost break will be logically 0, right? Because it's nothing less than 0 in this data set. Rightmost break will be maximal value of our petal width character. But what are middle 2 breaks? This middle 2 breaks should stay between 0.2 and 1.3. So 0.2 and 1.3, something in between. So logically it should be something like 0.75 in between, average. And also one break should be between 1.3 and 2.1. So it should be like y1.7. So this is how I will define breaks. And these breaks will serve as a model because we calculate these breaks from training dataset, but going to apply them to the testing dataset. So these breaks is a rule, instruction of how to make species from numerical values of force character in our training dataset. So this is what I'm going to do, to define these breaks. I will simply call it model. Model will consist of leftmost break 0, rightmost break, maximal value of Aries train petal width. This is a rightmost break, and I need 2 more breaks here. So I need to fill these empty spaces with breaks. So first break will be between 0.2 and 1.3, 0.75. So 0.2 will be just in between. And next break will be between 1.3 and 2.1. It is logically 1.7. So between 1.7 and maximal value will locate virginica. Between 0.75 and 1.7 will be versicolor, and everything which is below 0.75 should be Setosa. This is my model. And now I apply this model to our test data set. So I need a test data set. Only one character I need, because we already decided that we'll not use 3 first characters, only the 4th one. So I need the Aries test $, petal width, that's character number 4, and I want to cut it. Cut. How do I cut it? I cut it with my breaks model. And in addition, I like result to have some names, and logically it should be names of species. Very fortunately, species Setosa versicolor virginica correspond exactly with lowest, middle, and maximal value 0.2, 1.3, 2.1. Then I can simply extract species name in a way from levels. So levels of iris species would be my species name, which I will assign to intervals. And sorry, I need to specify labels. Labels equal to levels of iris species. And if you don't believe me, you can simply say separately levels of iris species, and you will see these 3 species names. Anyway, if I apply this one, I will receive names of species. I hope to receive them. Let us see it. Yes, I do. So there are some names of species, and to compare it with the real species names, I need to save this in some object. Iris PRED. Okay, and now we can make a table of misclassification confusion matrix from the original species names, which were not used for prediction, of course. Iris test species and our predictions. Wonderful! Results are even better than from linear discriminant analysis. Just look on them. We have 120 because we selected each 5th row, right? So we have 120 testing data rows, and of 120 only 3 were predicted in the wrong way. So 3 to 120 will be only 2.5, we can say 3%. Very high quality prediction. Why is that? Because we choose the right characters. So when we looked on our aggregate results here, we found that the last character is well working and probably will work for us. Actually, the answer to question how is because we're lucky. Our data set is very well done and it's easy to work with it. There are not much data sets of that quality. And just a warning about that way of prediction which I just showed to you. So this median prediction will likely not work for many other data sets. Iris data set is a kind of good exception. So that median learning is mostly demonstration of what is a model. Again, model is a system of break, how to break one variable to get species names. And what is a prediction? Prediction is a process when we apply breaks from training data to testing data. So this is our prediction. Okay, and now like my short assignment. Actually, there may be multiple assignments. First of all, we didn't really use R to do 2 things. First of all, we didn't use R to select best variable. We used our own brain. So we simply looked on that table and found that petal width is a very good variable. However, it will be interesting to think how to use R to select best variable. But this is not an assignment. My assignment will be simpler. So we also used our brain in a second case. It's when I define the model. So this 0 and rightmost value were of course automatically defined. But two middle values I simply calculated with my, well, kind of arithmetic skills. So I want you to think how to calculate 0.175 and 1.7, not like with your brain, but with R. So how to find these two numbers automatically to make our method slightly more portable. This is my assignment. And another question, again, which is not an assignment, but think about, is how well this prediction will work if we choose some other character. For example, if we choose a petal length, will it work better or same or worse? It's probably worth to check. So please think on my assignment, and this is all. Thank you very much.